Object-oriented programming. The major motivating factor in the invention of object-oriented approach is to remove some of the flaws encountered in the procedural approach. OOP treats data as a critical element in the program development and does not allow it to flow freely around the system. It ties data more closely to the function that operate on it and protects it from accidental modification from outside function. OOP allows the decomposition of a problem into a number of entities called objects and then builds data and function around these objects. Some of the features of an object-oriented programming approach are emphasis is on data rather than the procedure. Programs are divided into what we are known as objects. Data structures are designed in such that they characterize the objects. Functions that operate on the data of an object are tied together in the data structure. Data is hidden and cannot be accessed by external function. Objects may communicate with each other through the function. New data and function can be easily added whenever necessary. Follows a bottom-up approach in the program design. Next, OOP concepts. These are the OOP concepts. First one, objects. Objects are the basic runtime entities in an object-oriented system. They may represent a person, a place, a bank account, a table of data, or any other item that a program has to handle. They may also represent user-defined data such as vectors, time, and list. All objects are identified by some sort of characteristics. Programming problem is analyzed in terms of objects and the nature of communication between them. Program objects should be chosen in such a way that they match closely with the real world objects. When a program is executed, the objects interact by sending messages to one another. Next one, class. Class is a collection of objects having similar characteristics. The entire set of data and code of an object can be made a user-defined data type with the help of class. In fact, objects are the variables of type class. Once a class has been defined, we can create any number of objects belonging to that class. Each object is associated with the data of type class with which they are created. Classes are user-defined data types and behaves like built-in types of a programming language. Third one is inheritance. Inheritance is the process by which objects of one class acquires the properties of objects of another class. It provides code reusability. With the use of inheritance, the information is made manageable in a hierarchical order. The class which inherits the properties of other class is known as a subclass or derived class or a child class, and a class whose properties are inherited is known as superclass or base class or parent class. Next one is polymorphism. Polymorphism is the ability to take more than one form. An operation may exhibit different behavior in different instances. As the behavior depends upon the types of data used in the operation. For example, consider the operation of addition for two numbers. The operation will generate a sum. If operands are strings, then the operation would produce a third string by concatenation. The process of making an operator to exhibit different behaviors in different instances is known as operator overloading. Using a single function name to perform different type of tasks is known as function overloading. Next one is abstraction, data abstraction. Data abstraction refers to the act of representing the essential features without including the background details or explanation. Classes use the concept of abstraction and are defined as a list of abstract attributes such as size, weight, and cost, and functions operate on these attributes. They encapsulate the essential properties of the objects that are to be created. The attributes are sometimes called data members because they hold information, and the functions that operate on these data are sometimes called as methods or member functions. Next one is encapsulation. The wrapping up of data and functions into a single unit. That single unit means class is known as encapsulation. The data is not accessible to the outside world and only those functions which are wrapped in the class can access it. These functions provide the interface between objects, data and program. This insulation of data from direct access by the program is called data hiding or information hiding. Next one is dynamic binding. Binding refers to the linking of a procedural call to the code to be executed in response to a call. Dynamic binding means that the code associated with a given procedural call is not known until the time of call at runtime. It is associated with polymorphism and inheritance. A function call associated with a polymorphic reference depends upon the dynamic type of that reference. Next one, message passing. Objects communicate with one another by sending and receiving information much the same as the people pass messages to one another. A message for an object is a request for execution of a procedure and therefore will invoke a function in receiving object that generates the desired result. Message passing involves specifying the name of object, the name of function and the information to be sent. And the last concept is the modularity. Modularity is a general concept. It applies to in writing and implementing a program or computing the system as a number of unique modules rather than a single monolithic design. A standard interface is then used to enable the module to communicate. Partitioning an entire software constructs in distinct modules helps to minimize coupling, optimize application development and reduce system complexity. Modularity enables programmers to do functionality testing and in isolation and engaging in parallel development efforts during a given project. So these are our OOP concepts. Next, object-oriented programming language. An object-oriented language is a computer programming language that revolves around the concept of an object. Object-oriented languages were developed to make it easier to develop, debug, reuse and maintain software than is possible with the earlier languages. Understanding objects and object-oriented languages requires the knowledge of the evolution of computer programming languages and data structures. Examples of object-oriented languages are Java, Python, C++, C#, etc. Next, application of OOP. The promising areas of application of OOP include real-time systems, simulation and modeling, object-oriented databases, hypertext, hypermedia and hypertext, expert text, AI and expert systems, neural networks and parallel programming, decision support and office automation systems, CAM and CAD systems. So these are the a very short introduction about OOP. Thank you.